Hey, good evening, colleagues. My talk is about investigation of stage of adiabatic shear localization and failure. And at the beginning, I will give some motivation and then our experimental research. So, about motivation. At the beginning, researchers assume that strain localization under dynamic loading is mainly because of thermal softening. But later, scientists discovered that thermal softening on its own is not enough for start this instability. And many researchers starting development of some theories, approaches to investigate structure evolution, which leads to instability that actually ends with thermal effects. So one of these approaches is Naimar approach, collective properties of defects evolution. Another is approach of Rittel, dynamic recrystallization, and so on. Actually, we in dynamic experiments we do not have wide possibilities of investigation of this transient events. Even we cannot perform, for example, micro in situ micro CT or something like that. Even with DIC, digital image correlation, we have limited resolution because high-speed cameras have quite low resolution. So aim of the study is to extract maximum information from DIC images in order to identify different stages of localization. At the beginning, we started with more or less the same approach as my previous colleague, trying to find some features in space of strain and strain rate. So we are able to see some kind of cloud of points. We see some evolution, but nothing more. Then we decide to investigate more closely the features. So we decided to average strain rate and strain, and found that at the beginning of loading process, we see some kind of linear distribution, and at the end of the process, this linear distribution breaks into some chaotic pattern. Then we do another kind of averaging. So this is averaged strain versus time and averaged variation of strain versus time. Okay. Here we have some plot of averaged strain versus time. So we can see here that at some point strain are rising at more or less steady rate, and then at point of something around 70 microsecond, we observe thermal thermal localization. But more interesting is a graph where when we plot averaged variation of strain rate versus strain. And we found that there are some plateaus. One starting at the beginning and up to 0.2. Then another plateau up to 0.3. And then failure combined with rise of temperature. So actually, despite that we have a quite very low resolution image with more or less simple mathematical operations, we were able to extract features that represent different stage of strain localization. Okay, so as conclusion, so we did the high-speed imaging, then DAC image correlation, and from DAC images we extracted some features that reflects the evolution of strain field, which describes the evolution of structure of the material at high strain rate. And we assume that we have different two major stages. At the beginning, the evolution of structure, which results in some evolution of strain field on the surface of the specimen. And then when strain is already localized, we have rise of temperature and so on, which leads to final failure. So thank you for your attention.